Hello, my name is John Capobianco, and I'm a technical leader in artificial intelligence in the Cisco Secure team. Today, we're going to be looking at an advanced form of retrieval augmented generation, RAG. Don't worry if this is new to you, we'll cover RAG, but there was some feedback to a live stream that I did recently that thought the content was excellent, but was hoping that I would do some more advanced forms of RAG. So I did my homework, and over the past few days, I've been doing research and playing with incorporating this RAG fusion approach. So we're going to introduce RAG, and then we're going to introduce RAG fusion, and I'm going to do a live demo of chatting with different documents using this RAG fusion. Now I have a tool called Document Buddy that first implementation was just normal RAG using both OpenAI, ChatGPT, and Anthropic Claude to upload a PDF, a PowerPoint, a Word document, Excel file, um, other types of documents, and put it into the RAG system, appropriate file loader, transforming it into small chunks of text, putting it into a vector. Then we can retrieve that information and chat effectively with the document we've uploaded. Can we improve this, get the user better results using RAG Fusion? I would argue that we can. I'm going to explore that today. Thank you. All right, everyone. What we're looking at here is the LangChain retrieval augmented generation page. So many LLMs, right, applications require user-specific data that is not part of the model's training set. Primary way of accomplishing this through retrieval augmented generation. In this process, external data is retrieved, then passed to the LLM during the generation step. And it is a building blocks approach. And we're going to talk about these building blocks. So my source is the document the user uploads. And we've talked about the file types. Think different Word, PowerPoint, Excel, PDF, a couple of other file types. We need an appropriate loader to pick, so I use PyMu PDF for my PDF loader. I use unstructured Excel loader for my Excel. Different appropriate loaders depending on the file type. Then we need to transform it into small chunks of text. And for that, we can use a text splitter. Now, most people have been using, and I started with this recursive text splitter that you define, right? It splits on a list of user-defined characters every 1,000, every 500, every 2,500. Recursively splits the text. It wasn't very scientific. It was a lot of guesswork and trial and error and back and forth. I've now started to use this experimental semantic chunker that splits on sentences. Now, it does add some latency, takes a little longer, and it does cost a little more money in that we need to use the embeddings model, talk about that next, to help transform those sentences. Now, what are embeddings? You can see that we've transformed, say, the PDF from 100 pages into single pages and then sentences within those pages. Now we need to come up with the vectors, the spatial, think of a 3D space, the numeric floating point values that represent those text chunks. So we use a text embedding model. Now, you can use open source embeddings models from Hugging Face. I happen to use the OpenAI embeddings. And as they say here, embeddings create a vector representation of a piece of text. This is useful because it means we can think about text in the vector space and do things like semantic search, where we look for pieces of text that are most similar in the vector space. Now we need to store those things, our transformed chunks and our embeddings. So we use a vector store. And this is sort of right. We've loaded our data. We have loaded it, transformed it, and created our embeddings. Well, now we need to store it so that way we can query and retrieve most similar results. There's a lot of integrations here, and I've tried several of these, and I don't want to pick out anything in particular, right? Pinecone, Mongo, Elastic. I'm using Chroma. Chroma was the most popular vector store in 2023, according to LangChain. I can see why, because it's private and it's local and it's in memory. So it's fast, it's secure, it's private. I'm not relying on a cloud service to store things in the vector store. Okay, crash course on RAG. Everyone follows so far? Let's move on to RAG Fusion. And if you just Google RAG Fusion, the first hit is going to be this paper from Cornell University, I believe. Um, and it talks about combining RAG and reciprocal rank fusion, RRF. So what are we talking about here? So there's some other hits, there's videos. I'm not the first one to talk about this. I'm actually a little behind on this, I feel like. But the things I found are this wonderful LangChain RAG from scratch document, and part 6 covers RAG fusion. So how this works is our original question comes in. We're going to ask the LLM to generate, in this example, 3 similar questions. We're going to ask all 3 questions against our retrieval store, and then we're going to reciprocally rank them, and in my case, present the user with the highest reciprocally ranked answer. All right, so this gives, right, maybe the user didn't ask a refined question. Maybe there's a better way to word it. Maybe if we shotgun 5 or 6 questions, we can extract the best answer out of the AI. Now, fortunately, they've provided the reciprocal rank fusion function, or a starting point, and they've given you some examples here. There is also in the LangChain cookbooks an actual RAG Fusion cookbook. All right, so RAG Fusion, a search methodology that aims to bridge the gap between traditional search paradigms and the multifaceted dimension of human queries. Inspired by the capabilities of RAG, this project goes a step further by employing multiple query generation and the reciprocal rank fusion to re-rank search results. Now, in their example, they build a dummy Pinecone database full of 10 documents, and they ask a question about the impact of climate change, and then you can see the reciprocally ranked answers below. They even provide the fusion function, or a starting point for the fusion function. So with all that in mind, let's quickly see what ChatGPT says. Right? Could you briefly explain RAG, retrieval augmented generation, and new approach of fusion, and how RAG fusion moves basic RAG? See what the AI tells us here, right? So RAG is a technique that enhances the capabilities of generative models by combining them. Come on, let's go faster, faster, faster. A little slow today. We'll let this go. So while that question comes up, what I'm going to do is bring up my Docker container. So I'll come back to the code and show everyone the code. I'm very open about my code. This is open source, by the way. Let's just zoom a little bit here, show everybody. So I'm going to bring up my Docker container. And for those of you who don't know what I mean by a Docker container, I have dependencies, Python packages that it requires, and different things that it needs. And instead of giving you a README on how to build this from scratch yourself, I use a combination of a Docker file, all the stuff I'm pip installing, Python's package manager, and I'm even bringing up the service, meaning starting the Python script. I have a little script that does that, run streamlit run documentbuddy.py. Then I have a Docker compose that exposes the ports and it does some basic Docker compose. This Docker compose lets me say that Docker compose up, and it builds and brings up the container. And then this is the actual Python script. For you to run this yourself, there is a .env file here, or in the Docker Compose under your environment to add your OpenAPI key. And if you want, optionally, you can now even add an Anthropic key. OpenAI, Anthropic, one or both. And let's go back to ChatGPT. Still generating this answer. It's really slow today. So, and hopefully that doesn't affect the demo. Basically, what's going to happen is the bottom here, at the bottom of the code, have the chat interface. And this is the Streamlit interface where the user uploads the file, and that kicks off the process. Once the file has been uploaded, we load this chat with file class that invokes, initializes several things. And what we're doing is we're passing the uploaded document through that RAG process. If you keep it in your head, right? We are loading the file, splitting it into chunks, storing it in Chroma, setting up the conversational retrieval chain. That's all preparation. That way, right, we're storing it in Chroma. We are doing our OpenAI embeddings, storing it in the vector store. I'm using the semantic chunker to split my text by percentile. So sentences in the document by percentile. And that's what's being stored in the vector store with the embeddings. And then we have our conversational retrieval chain. As you can see, I'm using GPT-4 Turbo, the preview, and Claude 3 Opus, latest Opus. And that's pretty much the code. Where does the recursive stuff start to come in? Here is my chat function. A lot of it is in there, but you can see this is where I'm doing my ranked results and calling some other queries, where I'm actually invoking the text. So there's a couple of functions I want to show you in order. Collapse this. Okay, so generate related queries. I have this wonderful prompt that I'm not going to read the whole thing, but this prompt takes the original query and only respond with a JSON array, right? And we're going to see this. Don't worry. You're going to see this live in debug mode. So I generate the 4 additional queries, and then I take my original query and those related queries and loop over them. And as I loop over them, I invoke my retrieval chain to get the AI answer. From here, we then reciprocally rank them. There's that reciprocal ranking function that returns 3 ranked results with a score and the result. And I boil up the top result. So let's go back to ChatGPT. It is network error. See, it is slow. So I'm not going to hit regenerate, but right, there's too long to read. Maybe take a screenshot of this or something. But this was going to explain the difference, and I'm not going to push my luck here. So let's go to my service. Okay, so let's start with a simple file. And I'm going to show you this file to prove I'm not cheating or anything. This is a PDF, and you're looking at is the DevNet sandbox topology for the CML. So if you reserve a CML sandbox, this is at one point in time what it looked like. 4 devices, some VLANs, some routes, some OSPF, just a single page. Now I use this because it's small and lightweight, but we'll do a heavier file in a second. So we're going to upload the CML, and it's processed the PDF. Now we're going to proceed to chat. So I'm going to say, how about this? How many VLANs, and there's 5, by the way, are in this network topology? All right, so how many VLANs are in this network topology? We're going to click send, and we're going to start thinking about it. So the retrieval augmented generation process hasn't started yet. What we've started is, this is the raw suggestions from the LLM for the 4 additional questions. So my question was, how many VLANs are in this network topology? The LLM suggested, what are the maximum number of VLANs supported by the switches in a specified network topology? Can you list the VLAN IDs and their associated subnets present in a given network schematic? how does the implementation of inter-VLAN routing affect the total count of VLANs in a complex network diagram? What are the VLAN configuration details and the interconnects between enterprise level network maps? So they're not all perfect, but it is a variety of questions that then I'm going to loop through. So here's my original question, and it may likely be the best answer that we get, right? There are 5 VLANs, and here's the VLANs and their subnets. Here's the next question, and it actually says, based on this provided context, no specific information about the exact switch models for disk switch 1 and 2. This is using my RAG document as I shotgun through these 4 questions, right? And here's another response for my third question about how does it affect the total count, and a decent answer here. And then, what are the VLAN details and the interconnection which is in that? Based on that, and here's the VLAN details and the interconnection, and then the host and management details. I'm actually getting some really good data out of this fourth answer, right? So now I just like to dump for my own knowledge. Here are the 4, the original and then the other 4 questions before I send them to be ranked, just in the raw order. And then now here's the ranked results. The rank 1 is my original question and answer. Yeah, I'm surprised it didn't rank the 5th one higher. So it did give me the top answer. There's 5 VLANs configured in this network topology. Pretty interesting, pretty interesting. So I'm getting all of them and then my top ranked answer there, even though there's a lot more details in some of these other answers. Now I'm still playing with this. And I want to really make sure that the reciprocal rankings are not just order here, 0, 1, 2, 3, 4. I want the reciprocal ranking to give it the ranking. And maybe it's not. I need to look into that and confirm that it's not. But that's the idea, is that we're going to ask multiple questions, get multiple answers back, and then extract the best answer. So there are 5 VLANs configured in this network topology. Now that's the top ranked answer. Now where did it get that answer from? Rank 1, right? And there is the score there. So there's the actual score. This is what I want to rank on for. So let's check the other scores. 01639, 01587, 01538 is the lowest score so far, and that one's last. There's the score. So it does look like I am ranking them, because this is rank 2 has a lower score than rank 1. So, phew. Now, I think this is actually incredible. Now, I'd like some feedback. Should I present all of the answers for the user to see them in the questions, like I'm sort of doing now, without the debugging? Should I just boil out the top answer, which is what I'm doing right now, if I took out all the debugging? Another thought was, could we take the 4 answers and 4 questions and maybe take the top 2 or 3 that are scored the highest, send them back to the LLM and say, here's the top 2 answers. Could you give me a new best answer from the information from these top 2? And maybe add a 3rd level to this. Once we've reciprocally ranked, take everything above a certain score maybe, and combine them into an answer. Lots of possibilities. Let's do one more, just because we can. And I'm just going to refresh this. I have to add logic to this code, that maybe where I push a button, it refreshes the database. So I don't have to do this. But for now, we're going to upload a new document. And let's grab a PowerPoint. We just did a PDF. So let's just grab a PowerPoint. And I'm going to grab my Cisco Live presentation from Cisco U Theater. And this might take a second or two to load. And while it loads, oh, there, ready to go. So how about this, right? Could you please provide a summary of this presentation and provide highlights and important, right? And your prompts are going to vary. This is kind of hard because I'm just asking for a summary. But let's just see what other questions LLM comes up with in addition to my original prompt. So here are the parsed query results, the 4 additional questions, summarize the key points and core themes of the recent presentation, emphasizing the most impactful data and insights presented. Excellent query, right? Identify the top 3 takeaways from this presentation. It influences strategies or decisions and support statistical case study. So it actually could give me a better prompt or deeper insights. So here's my original query and the answer that we're getting. And it's a pretty good summarization, highlighting the important parts. And now here is the other one about summarizing the key points. And it's a, similar information presented in a different sort of summary format. And it's going to ask the next 2 questions. And I'm going to see, hopefully we can get some scores and see which one it likes the best. Top 3 takeaways. Adoption of for network engineering. Yeah, that's probably my top takeaway. Leveraging PyETS for testing and automation. Yep, part 2 would definitely be that. Utilization for network state validation and differential analysis. Pretty good top 3 from this PowerPoint, to be honest with you. And I think it has a 4th question to ask here. Working. And while it's working through that, I just want to show you, in case you're curious, I use Streamlit.io. This is what I'm using for the front end. Check it out. Import Streamlit as st.write, my hello app. Boom, there's my hello world. Go to generative AI, ties in Anthropic, LangChain, build the chatbot. Incredible little proof of concept tool. And then here's the 4th answer. Strengths, areas of improvement after future research. Here's all my results before I rank them. Now here are my ranking. And what's the top ranking? 601. 5.8. 6. Oh, here, top rank. Those, yeah, so those are the scores in order. And there's the top answer. So we've done a couple of documents here, working very, very well. Adds a little bit of latency, sure, but I don't think latency is something that we need to be concerned. So that's RAG Fusion, evolving from RAG to RAG Fusion, where we're generating additional prompts, reciprocally ranking, and then boiling up the top answer. So if you have any questions, let me know. This code is open source. Because of my success during the demo, I'm going to be pushing, merging it into a branch of Document Buddy. So all of this code will be in the Document Buddy repository. My next step will be to refactor my Packet Buddy and chatting with routing tables. Those sort of other projects. I had to start somewhere. I thought the Document Buddy would be the best, most universal use case. I'll do Packet Buddy next, followed by Routing Buddy, chatting with you. All right, everybody, this is really exciting.